section 4.2 on the unit circle. So we're going to start with some basic trig ratios that you learned in geometry. So we learned that sine of an angle is the opposite side over the hypotenuse of a right triangle. The cosine of an angle is the adjacent side over the hypotenuse. And the tangent of an angle is the opposite side over the adjacent. So if we look at a right triangle here, and I'm going to label the sides ABC, and then that makes the angles ABC also, but we label the sides with lowercase letters and the angles with capital letters. So if I'm going to find these three trig ratios for this triangle, then you need to pick an angle to start from, and I'm going to use angle A. So the sine of angle A is going to be the opposite side over the hypotenuse of the triangle. So sine of A is going to be A over C. Okay, then I want to look at the cosine of angle A. The cosine is the adjacent over the hypotenuse. So the cosine of A is going to be side B over side C. And then the tangent of the angle is the opposite over the adjacent. So if I'm going from A, opposite over adjacent, then that's going to be side A over side B. So we can use these ratios for right triangles, but they can also be applied to circles and other things that we're going to be using in Chapter 4. But we have to understand the basics of these ratios first. Okay, so let's talk about the reciprocal functions. Those three trig functions that we use have reciprocals, which just means you flip it over. And those functions are the reciprocal functions. So, for sine of an angle, the reciprocal is called cosecant. So sine of an angle equals 1 over cosecant of that angle. And it also works the other way, that cosecant of an angle equals 1 over sine. For cosine of an angle, the reciprocal is 1 over secant. So then secant of that angle is 1 over cosine. And then the last one is tangent. So tangent of an angle equals 1 over cotangent, and cotangent equals 1 over tangent. So we use those interchangeably when necessary. Okay, and those will be used in other types of trig ratios and functions that we'll learn about later. Okay, so next we're going to see how this right triangle trigonometry can be applied to this special circle that we call the unit circle. So we're going to start with a circle of radius 1. That means it's one space in all directions. Okay. So I'm going to go ahead and label these 4 points around the circle. So first on the positive x-axis, this is 1, 0. Straight up is 0, 1. To the left is negative 1, 0. And at the bottom is 0, negative 1. Okay, if I take a triangle and put it on the circle here, the radius is always going to be 1, so there's still a 1 going for the hypotenuse of this triangle. And we know that going left or right represents the x-coordinate, and up and down represents the y. So there's a point out here on the circle where our triangle meets from the vertex, the angle touching at 0, 0, out on the circle. That point would be x, y. So this is going to be important for us in a minute. We're going to find some values out on this circle that are not the 4 points on the edge. Okay, so let's look at those three trig functions and see how this applies. So if I start from this angle, then the sine of this angle is going to be opposite over hypotenuse, which is y over 1. And we can just simplify that to equal y. So the y coordinate is the same as the sine of that angle. Okay, if I look at the cosine of this angle, cosine is adjacent over hypotenuse. That's x over 1, which would just equal x. So the x part of our coordinate is equal to the cosine of the angle. So when you see the ordered pair out on the circle, we're going to remember that those ordered pairs are also the cosine and sine values for any angle that's coming from the origin. Okay, and then the tangent is opposite over adjacent, which would be y over x, and is also could be considered the sine divided by the cosine. So we'll remember that for later, that the sine divided by cosine is equal to the tangent. Okay, let's go back to geometry for a little bit, and we're going to review some special right triangles that we learned. The first special right triangle is the 45, 45, 90. And in geometry, you learn the rule that the hypotenuse of a 45, 45, 90 is equal to the square root of 2 times the leg, since the two legs are equal here. We're going to make our hypotenuse be 1, because we're going to be putting these triangles on our circle here in a minute, and I want them to all have a hypotenuse of 1. So if the hypotenuse is 1 and I want to solve for the leg, I would have to divide by the square root of 2. So the leg would actually be 1 divided by the square root of 2, which is equal to the square root of 2 over 2. We know that both legs are equal, so I'm going to go ahead and put the other one as square root of 2 over 2 also. Okay, next we've got the other special right triangle, which is the 30, 60, 90. And we had two rules for a 30, 60, 90. The first rule is that the hypotenuse is always 2 times the short leg. And then the long leg is always the square root of 3 times the short leg. So we're going to again say our hypotenuse is 1. So if I'm going to solve for the short leg and then the long leg, let's start with the short leg. So if the hypotenuse is 1, we're going to have to divide by 2 to get the short leg. So that means our short leg is going to be 1/2. And then our long leg is always the square root of 3 times the short leg. So that's going to be the square root of 3 over 2. Okay, these three angles, 45, 30, 60, are special angles that we use a lot in trigonometry. So we're going to take these triangles and we're going to put them on what's called our unit circle, and we're going to find some important trig values on our unit circle that will help us later on. Okay, so we're starting with the same circle that we had a while ago, and right now we're just going to look in quadrant 1 and kind of fill those in with our triangles, and we'll come back and fill in the whole circle in a little bit. So I'm going to start by putting the 30, 60, 90 triangle in quadrant 1, where the 30-degree angle is coming from the origin and the right angle is on the x-axis. Okay, a while ago we said that that ordered pair sitting out on the circle is the x comma y, and it's also cosine comma sine. So if we use the lengths of our right triangle here, we go square root of 3 over 2 spaces to the right, and then 1 over 2 spaces up. So that means the ordered pair out here on the edge of the circle is the square root of 3 over 2, comma 1/2. Okay, so we're going to take our next angle and put it on the circle, which is our 45, 45, 90. So if I look at this triangle, again, we want the x direction and then the y direction. So that point that touches out on the edge of the circle is the square root of 2 over 2, comma square root of 2 over 2. Okay, we're going to take our next biggest angle, which is 60 degrees. So you can imagine if you rotated that 30, 60, 90 around a little bit, if you've got the 60-degree angle coming from the origin, then it's going to flip those sides around. So this time we're going 1/2 of a space to the right and then square root of 3 over 2 spaces up. So that's the ordered pair, 1/2 comma square root of 3 over 2. Okay, so this gives us some important values on the unit circle in quadrant 1. So we're going to go through and fill all of these values in around the circle, and I'm going to zoom in up close so we can see them a little bit better. Okay, so we're going to start down here at the bottom on the positive x-axis, and we know that this is 0 degrees, which is equal to 0 radians, and this is the ordered pair 1, 0. Okay, our next line up is 30 degrees, which is equal to pi over 6 radians, And we just found that that ordered pair was square root of 3 over 2, comma 1/2. My next angle is 45 degrees, which is pi over 4 radians. The ordered pair is square root of 2 over 2, comma square root of 2 over 2. Our next angle is 60 degrees, which is pi over 3 radians, and that ordered pair is 1/2, comma square root of 3 over 2. Okay, then we're going to go straight up, which is 90 degrees and equal to pi over 2 radians, and that's the ordered pair 0, 1. So this is quadrant 1 of our unit circle. All of these important angles in degrees, in radians, and then their ordered pairs out there. Okay, so now we're going to go to quadrant 2. Okay, and we're going to have 3 more lines. These are the same angles, the 30, 45, and 60. We're just going to be adding those to 90 degrees, and it's going to carry on the degrees as we rotate around. So the first angle that we come to is going to be 120 degrees, and that is equal to 2 pi over 3 radians. This time, because we're going to the left and then up, our ordered pair will be negative 1/2, comma square root of 3 over 2. Our next angle will be 135 degrees, which is 3 pi over 4. Our ordered pair is negative square root of 2 over 2, comma square root of 2 over 2. Next angle will be 150 degrees, which is the same as 5 pi over 6. Our ordered pair is negative square root of 3 over 2, comma 1/2. Okay, then we're going straight to the left. This is 180 degrees, which is equal to pi radians, and our ordered pair is negative 1, 0. So notice in quadrant 2, all of the first numbers are negative, the second numbers in the ordered pair are positive. Okay, now we're going to go to quadrant 3. So again, we've got those same 3 angles in the middle, 30, 45, and 60. We're just going to be adding those to 180 degrees. So next up is 210 degrees, which is 7 pi over 6. The ordered pair is negative square root of 3 over 2, comma negative 1/2. We're going to the left and then down, so it's going to be negative, negative. Our next point is 225, comma 5 pi over 4. And our ordered pair is negative square root of 2 over 2, comma negative square root of 2 over 2. Next is 240 degrees, which is 4 pi over 3. Our ordered pair is negative 1/2, comma negative square root of 3 over 2. Straight down is going to be 270 degrees, which is 3 pi over 2. And our ordered pair is 0, negative 1. Okay, now we're in quadrant 4. So our next angle from 270 is going to be 300 degrees, which is 5 pi over 3. And our ordered pair this time is positive 1/2, negative square root of 3 over 2. We're going to the right and then down. So that's positive, then negative. Our next angle is 315 degrees, which is 7 pi over 4. That's the ordered pair square root of 2 over 2, comma negative square root of 2 over 2. Next is 330 degrees, which is 11 pi over 6 radians, and the ordered pair square root of 3 over 2, comma negative 1/2. Okay, and then once we go back up, we're back to 360 degrees, which was the same as 0, and 2 pi, which is the same as 0 radians, and our ordered pair is still the same, 1, 0. So as we're going around, you probably noticed a few things. A lot of these numbers repeat. The angles you'll have to get used to, both the degrees and the radians. You'll have to learn and memorize those. And there's a few tricks to learning all of the different information on here, but eventually you will have it all memorized. So let's look at the whole thing. So here's the whole unit circle. Lots of information. So it's important to remember that the ordered pairs are the cosine comma the sine of the angle. So if I want to know any particular sine or cosine value of any of these angles, I can just look at the ordered pair. Okay, we also learned earlier that the sine divided by the cosine is the tangent value. So we're going to go around really quick and just fill in all of those tangent values, and you'll start to notice a few little patterns. So we're going to start over here at 0 degrees. So it's the sine divided by the cosine. So if I do 0 divided by 1, that's going to be 0. At 30 degrees, 1/2 divided by the square root of 3 over 2 is 1 over the square root of 3, which we change to square root of 3 over 3. Next, square root of 2 over 2 divided by square root of 2 over 2 will equal 1. Square root of 3 over 2 divided by 1/2 will equal square root of 3. And then straight up, 1 divided by 0 is undefined, so we just write UND. Okay, now we're going to start to see a pattern with all of these numbers. We've already divided. All the sines and cosines are the same numbers, but their signs are going to change in different quadrants. So if you notice in quadrant 2, when I do square root of 3 over 2 divided by negative 1/2, that's going to become negative square root of 3. So all of the tangents in this quadrant are going to be negative because you're having a positive divided by a negative. So it's the same numbers, just all of those are negative. Okay, now we go down to quadrant 3. This time we're doing a negative divided by a negative, so it's going to be a positive. So the first one up is square root of 3 over 3. Next will be 1, and then square root of 3. And then in quadrant 4, same thing. This time we're doing a negative divided by a positive, so we're going to wind up with a negative answer. Down at the bottom at 270, negative 1 divided by 0 is undefined again. Okay, so last in quadrant 4, these are going to be the same values, just negative. So negative square root of 3, negative 1, negative square root of 3 over 3. So we just added a lot more information. If you can memorize quadrant 1, then that helps you memorize the whole unit circle. You just may have to memorize what sign is positive in each quadrant. So let's look at that. If you notice in quadrant 1, if I'm looking at the cosine, the sine, and the tangent, in quadrant 1, all three of those are positive. So I'm going to put an A here for all are positive. If I go to quadrant 2, notice that the tangent, the cosine are negative, but the sine is positive. So I'm going to put an S for sine is positive. In quadrant 3, only the tangent is positive, so I'm going to put a T for tangent. And then in quadrant 4, notice that only the cosine is positive, so I'm going to put a C for cosine. So what I learned when I was in calculus or in pre-cal in college is that ASTC stands for all students take calculus. That's how we memorize to know what is positive in what quadrant. All students take calculus. So if I can't remember if something is positive or negative in a quadrant, then I just remember all students take calculus, and that tells me what's positive in that quadrant. Everything else should be negative. Okay? So just a helpful tool to help you memorize those things. Okay, here's another way that you can memorize this information. We also made a graph or a table when I was in college that we just memorized this information in the table, and then later we're going to learn about what are called reference angles. If you know the information in this table, you can know any value anywhere on the unit circle that have these angles are equivalent to these angles. So I'm just going to fill in the chart. We already have this information. I'm just going to put it in the table form. So at 0 degrees, the cosine is 1, sine is 0, tangent is 0. 30 degrees, the cosine is square root of 3 over 2, sine is 1/2, so then the tangent is square root of 3 over 3. 45 degrees, cosine square root of 2 over 2, sine square root of 2 over 2, tangent is 1. 60 degrees, cosine is 1/2, sine is square root of 3 over 2, tangent is square root of 3. And then 90 degrees, cosine is 0, sine is 1, and then the tangent is undefined. So if it's easier for you to look at this table of information and memorize it, then that may be easier than looking at the unit circle, which is a lot more information. Whatever works best for you. But this is the nitty-gritty information that you have to have memorized, and then you can figure out everything else based off of these things. Okay, just a couple more things. We're going to talk about even and odd functions. So the next thing is if I'm looking at kind of the right-hand side of that unit circle, these would be the positive and negative angles that are the same. So if I think about positive 30 degrees and negative 30 degrees, those are those two green lines there. And if I compare their cosine, sine, and tangent values, we want to look and see what's positive and negative. That determines what's even and odd. So the even functions, if you notice, the cosine values are the same in quadrant 1 and quadrant 4. The sign didn't change. So they're called even functions. So cosine of a negative angle is equal to the cosine of the positive angle. It's also true of its reciprocal, which we'll learn more about later, so that secant of a negative angle is equal to the secant of a positive angle also. Okay, the rest of the trig functions are odd functions. So if you notice the sine and the tangent on quadrant 1 and quadrant 4, those are opposite signs. Whatever they are, they're an opposite sign. So for the sine of a negative angle, it's going to equal the negative sine of that angle, or the opposite. Okay, that's true of its reciprocal, cosecant. It's equal to the negative cosecant value. Tangent of a negative angle is equal to the negative tangent value. And then cotangent of a negative angle is equal to the negative cotangent value. So you just have to remember that cosine and its reciprocal are even functions. They're going to stay the same value, while sine, tangent, and their reciprocals are odd functions. So it's going to change the sign or be opposite.